we get this going on. So logarithms are the inverse of exponentials, which we were just doing before. Okay. Logarithms are the inverses of them. So if you have an exponential, a to the x equals y. Actually, I'm going to rewrite it the way they do. A to the y equals x. Okay. This is true if and only if y is equal to the log base a of x, where a cannot equal 1. Okay? So you can write any exponential as a logarithm, and you can write any logarithm as an exponential. And just something also to take note of, this x right here must always be positive. You can't make it negative. You can't take a log of a -5. It doesn't make any sense. And you'll see why when we start doing things in a minute. So logs and exponentials are interchangeable. And so I'm going to teach you how to convert one into the other. And it's very easy. And I call it actually it's literally what I use when I teach my students. I call it the Joop method. And I say that every time we do it because it gets in their head. I know it's silly, but it works. So if I said write in an exponential form, remember exponential looks like this. Something to a power equals something. And it's really easy. You start on the left and you start at the base. You wrap around and point. And you, like, as I say it, I go zoop like that. And so you would have a base of 2, base 2. That's your base, log base 2. What you wrapped around becomes the power, 3, equals what you point to, 8. And isn't that true? 2 to the third, is it not 8? 2 times 2 times 2. So let's do it again. So this one, I want you to write exponential. You start at the base, wrap around, point. Zoop. 1/2 is your base. Power of 4 equals 16. And that's wrong, by the way. I can already tell. This should be a negative. So sorry about that. That was my bad. And I knew it because I was like, that's not going to work out. But 1/2, and you can check it, to the power of -4 is equal to 16. Yeah, there we go. That was a typo. Sorry about that. So base, wrap it around, point. Now, let's do it the other way. You can write any exponential as a log. So exponentials are easy, right? You can write them as logs. Log of what? Log of that base, whatever that base happened to be. So you do the same wrap around, zoop, like that. So you start here at the base, the 5 on the left, wrap around and point. But when it says write a logarithmic form, you're going to write the word actual log. You're going to write that word log. Log of what base? Well, what did you start with on the left? You started at 5. So write a 5 here. What did you wrap around? You wrapped around 5 equals, what do you point to? You point to the exponent 1. And you can check it by doing the zoop again. Look, 5 to the 1 equals 5. Oh, yeah. So let's do it on this side. This is your base. Wrap around, point to the exponent. And write the word log. The base is 1/4. You wrapped around a 1, and you equal the exponent 0. Now, you can check this, and I'm going to show you. If you have the TI calculators, which you should, there is an awesome button, y'all, called Math right here. And if you go down to where it says log base, Math log base, log base. And if you hit enter, it actually does that for you, gives you a little placeholders, and you can type in like 5 here, 5 here, and let's see if it equals 1. It does. And so you can actually do any logs. You could do math log base, and you could put 0.25, which is 1/4, and put 1 right here, and it'll say 0. So the calculator will do it for you on math log base, which is awesome. All right, we'll take a break. We'll come back with this. Here we go. All right, so we got a couple things to now solve for. So when you see a log on one side and they ask you to solve, you see one log on one side, you're going to do this method that we just learned before, which is this zoop. You got to zoop around. I like the log to be on the left. Okay, so for example, and I'm going to write that down, log on left. So I want this to say log 8/4 equals x. I like my log to be on the left-hand side. And then I can do my zoop method. So I take my base 8 and I raise it to a power of x and I set it equal to 4. Now this is an exponential function that I can solve, and that's what we just learned in the last lesson. So how can I get these two to be the same base, Well, I can make them both into base 2, not base 4. 4 to the 1 power is 4, 4 to the 2 power is 16. So, but I can get 8 to become a 2 to a 3. And since there's an x right there, I can go like that. I can get 4 to be 2 squared. So really, this is 3x equals 2, because these are the same base. So x must be 2/3. So one log, one side, you go around. Let's do that again. Here's my base x, wrap it around, point. X to the 4th power equals 16. Well, now, this is one that we can solve. We've been solving this now for a couple of sections. How do I undo a 4th power? I just take a 4th root. And that would be x equals, and normally it would be plus or minus, the 4th root of 16 is 2. But you can't have your base be -2. Your base is always just a positive. You know, we don't write -2 base. If we want a flipped version of it, we would put 1/2 or something. So it's not the -2. It can only be the +2. And again, you can check this by putting it into your calculator and typing under that log base button that I showed you before. All right, this one, zoop, wrap around. 4 to the 3/2 equals the x. So this just means what again? This is really just the square root of 4 and then cube it. You can punch this into your calculator, obviously. I'm just going a little extra here. So let's see, that's square root of 4 is 2, 2 cubed is 8. So easy peasy stuff when you have to solve it. All right, now there's this idea of common logs, and common logs is actually what is most on most calculators. Not really the graphing ones have them, but really like your 4 function ones, like maybe your son or daughter, if they're in like 5th grade, has like a 4 function calculator. Maybe you have one at home. But a common log is when you just see log x, and what's understood is the base is that it's a base of 10. Common logs are base 10. Common logs are base 10. So again, this right here, 10 to the -2 equals 0.01. If I do the whole zoop wrap around, I can write the logarithmic form by saying log, my 10 is my base, wrap around goes right here, 0.01. equals my exponent. But you really don't need to write that 10. You just have to write log 0.01 equals -2. And there is a button on your calculator. If you look right here next to the number 7, it says log. If you just type log, log of 0.01, you get -2. And so that only the common log is that button right there where it says log. And like I said, most 4-function calculators, even your phone has it on the, you turn your calculator to the side, it'll have the log button. And that's only for base 10. So part of homework tonight will be to evaluate common logs, which again is just as easy as putting it into a calculator. So all of these are common logs because they don't have bases. So you would just type log 12 and you get 1.079 roughly. It'll tell you on on Pearson how far to go to. This one, log 0.1 is -1. Log 3/5, 3 divided by 5 is -0.22. My dog is chewing on a bone. If you hear weird sounds, sorry about that. This one, log -2. Not real. It's undefined. Because you cannot take a log of a negative x value, and that's what I wrote up here. X must always be positive. It's always got to be positive. So that's why you'll get an undefined answer. Now, natural logs, some of my favorites. I love the natural logs. Those are also on the calculator. So this is, again, was all calculator. Natural logs are on the calculator, and they are ln, the ln of x. And you'll see calculator button right here next to like the number 4 under the word log is ln. Now, a lot of my students are like, why did they call it ln and not nl if it's natural log? And it's because it's from Latin. It's like logarithmicus naturalis or whatever. So they just chose to call it ln. But what it means is it is really log of a base e. E being that number 2.71, that irrational number. So it really is a log of a base e, but we rewrite the log and the e to be ln. And again, there'll be parts of homework tonight where they ask you to like evaluate it. And again, you can just use your calculator. And we'll do ln of 12. And we get 2.485. And we'll do ln of e to the 10. So ln, the e is above that ln button, e to the 10. And look at that, just became 10. That's very important. Okay, and I'll tell you why in a minute. This one is ln of the square root of e. The square root of e, I think I'm going to just write e to the 1 because that's what e is. And it's 0.5 or 1/2. Now this one doesn't have an ln, but I'm going to show you how to evaluate this in your calculator. Again, you're going to type, and if you don't understand what this is writing, I had to write it pretty big. But there's a reason for this, because there's these properties that we're going to find out in a minute. This is 12.19 to the power of, and the power is log base 12.19 of 84. So let me do that real quick. Let me do log base, which is math log base. And my base, according to this, is 12.19. Oh. And it's of 84. And I'll hit enter, and look at that, 84. So what you've actually just done in the calculator are a few properties here that we're about to find out about logs. So this is, again, ln e of 10, which ln is really log base e of e to the 10. And notice what happened to my answer. Log base e of e was just the 10. Same thing here. I could rewrite this as really log base e of e to the 1/2. Log base e of e cancels. So an ln is actually the inverse of e. They actually undo each other. They're inverse operations, ln and e and ln. They inverse each other. The same applies to if you have an exponent raised to a log of that base. Those cancel each other out. So 12.19 to the power of log base 12.19, those cancel each other out and you're left with whatever the exponent is. And these are just some common properties that occur. So let's write some of them down. So log base A, whatever the base happens to be of the number 1, it's always 0. Log base 2 of 1, log base 3 of 1, log base 1/2 of 1. And that's, again, if you go zoop, you would say 2 to the 0 equals 1. And that's true. Anything to a 0 power makes 1. The next property says log of a base A. So log of base A, and then you have A to the K. Well, these 3 things, log base A of A, log base E of E, log base E of E, they just cancel and you're left with K. And then if you had a base of A raised to a log base A, so the same base right there of K, that also was K. That was like this example up here, where you have 12.19 to the power of log base 12.19. Whatever was next to it, like 84, that would be your answer here. Okay. So again, just to show you how these work, and again, you can use your calculator for them. I'm not upset, but just to show you, log base 13 of a 1, log base anything of 1, that equals 0. And again, you can use your calculator for it. ln of e, they really cancel each other out because ln of e is really log base e of e to the 3/5, and that is your answer, 3/5. 2 to the power of log base 2. As long as the base here and the base here are the same, they cancel each other out, and your answer is 3. And again, you can completely use your calculator for that, but it's pretty easy stuff. All right, some more properties. I know you thought we were done. A few more properties. Oh, good, we're almost done. We have a product rule, a quotient rule, and a power rule. And this is where it can start get complicated, so you kind of need to pay attention. I will say most of my students usually like log properties. They're easy to understand, but you want to pay attention. The product rule says that if you have a log of whatever the base is, let's call it A, and you're multiplying two things together, okay? So like 2x, xy, whatever that happens to be, you can actually expand it to say log base A of x plus log base A of y. And that's because, think about it, these are just exponents. What do you do when you have the same base and they have different exponents? You add them. So if you had like 2 to the 5 times 2 to the 7, that's really the same as saying 2 to the 5 plus 7, 12. So multiplication can turn into addition. Quotient rule for logs says that log base A of x over y when you subtract, I just gave it away. When you divide two exponents, you actually subtract their exponents, two bases. You do the top minus the bottom. And then the power rule is one of my favorites, and we'll use this one quite a bit when we solve. Log base A of x to the r power. Any power that's next to this can actually be moved to the front. It's really r of log base A of x, log base A of x. And so you are going to be asked to do it both ways. You're going to be asked to what's called expand, which is this right side. This is expanding, making a bunch of logs. If they ask you, though, to condense, they want one log. So the first three examples here on this side are expand, which means you need to write the word log a lot, like log of this plus log of that minus log of this, log of that. Okay. So let me teach you how I would do this. I start with the grouping, the most common grouping symbol that they say I see right here, which is this division sign. And division means subtraction. So I'm going to do log base A of the top, x squared, minus log base A of the bottom, yz. But now look at what you've written, and you need to see if you can expand them even further. So like this one is really a power rule, because this has a 2 right there. So I can actually pull that 2 to the front. 2 log base A of x. This one is really a multiplication of two things. That's what that was up here. So I can write it as addition of logs. So log base A of y plus log base A of z. Now, the only thing is I have to put this in a parenthesis because there's a minus right here. So I have to do that. And I'm not sure, I can't remember. I think Pearson actually wants you to distribute that negative. So really your final answer would be 2 log A of x minus log A of y minus log A of z. And that is the expanded form of that. Okay, so you take the most, looked at, like when you look right at it, you can see that division symbol right away, and that means minus, and you start there. All right, now we're going to do B. We're going to write this in an expanded form. Anytime you see square roots, you want to write them as powers, square roots or cube roots or any kind of roots. So this is really log base A of m to the what power? Well, this is your denominator, so 2/3. But where can I put that 2/3? Because that's a power. The power rule says I can stick it in front. So this is really 2/3 log base A of m. And that's it. There's really nothing more I can do. I mean, that's as easy as it gets. But this one, so let's use this knowledge that we just did with these two together. I'm pretty sure we can do this one very easily. So let's see. Log base 5 of 5 square root of 2 divided by 11m. I always do that division part first because that's what sticks out to me. So I'm going to take log base 5 of my top, 5 root 2, minus, right, log base 5 again of the bottom. Now let's see if I can expand this even further. These are both multiplication, so I do have to expand them further. This would be log base 5 of 5. If it's times, you would write plus log base 5 of square root 2. But really square root of 2, I'm just going to write it as 2 to the 1/2 because we all know that that's square root 2. This one is log base 5 of 11. The times you would put plus log base 5 of m. But again, put this in parentheses because there's a minus right here. Now let's see what else we can do. Log base 5 of 5. Hey, you know what? That is an actual number. Log base 5 of 5, and we just learned that property, they cancel out to whatever the exponent is right here, which is 1. And you can put that in your calculator if you want to. Log base 5 of 5, it equals 1. This one, this has a 1/2 in the power, so I'm going to bring that to the front. So plus 1/2 log base 5 of 2. This minus, I'm going to distribute it, log base 5 of 11. And this minus, I'm going to distribute it, log base 5 of n. And really, there's nothing more you can do here. If this was like a 25, you might be able to simplify it more, but this is not. It's just going to be just like that. So this is how you expand. You just write log minus log plus, and you expand and expand and expand. Well, now we're going to work backwards. If you can expand, you can condense. If you can do both, you're doing amazing. So now we want to condense, which is 1 log. Your final answer can only contain 1 log, okay? So I start with, usually I start with my powers. So that's usually what I start with. I always go to the powers in front and I move those. And then I do the addition or the subtraction, like powers. So I always do the powers in front. If it has a power in front, I move that. And then I do the addition or subtraction. So for example, again, we're condensing it. We're making this to be 1 log. So we're going backwards what we were just doing. So I see a 2 in front. And then over here, I see 4 in front. 2 in front, 4 in front. So I'm going to take that 2 and I'm going to make it the power of just the x. So this is log base b of x squared. Minus, I'm going to take that 4 and bring it up to the y cubed. Which really, I mean, that cube should have been brought down, but that's okay. It didn't. Log base b of y to the now 12. 4 times 3 is 12. All right. Once I do the powers, then I usually look at what the operation is in the middle, which this one is subtraction. And subtraction just means division. And what you're dividing by is next to the word logs. So you're going to now condense this to be 1 log. And you're going to have the x squared, whatever's on the left comes on top, whatever's on the right goes to the bottom. And you just condensed. That's how easy it is. Do your powers, then do your addition or subtraction. Let's do another one. 2 log a z plus 1 plus log a 3z plus 6. Okay. All right. Again, I try to go for my powers first, which 2 is a power right here. So I'm going to bring that up. So this is log base a of z plus 1 squared. This one doesn't have a power, so I'm just going to write it again. Now, what does plus mean? Plus means to condense, it means multiply. So log base a would be my base, and then I would take this and multiply it with this. Z plus 1 squared times 3z plus 6. And I actually think they're nice, and I don't think they make you FOIL it out. At least I hope they don't. But if they did, they would FOIL this and multiply by that, but I'm pretty sure they let you leave it like that. All right, last but not least, 6 ln x minus 4 ln y. Now again, ln is really just log base e. Just don't forget that. ln is really a log base e, okay? So we can do the same properties to ln's that we do to logs. So this 6 is going to become a power. This 4 is going to become the power. But we're going to keep the ln. That's going to be our log. So ln of x to the 6th, that's the power, minus ln y to the 4. And then again, there's that minus. Minus to condense means to divide. Divide, this becomes the top, this becomes the bottom. So ln x to the 6th over y to the 4. And that's nothing else you can do. And by the way, you keep that ln on the outside. You don't put it to the top. You just keep it on the outside. Like this is the ln of this right here. All right, last and final thing is this change of base rule. And it's unfortunately not used as much anymore because of what I showed you tonight. Sorry about that. I know you're upset that I showed you all these tricks here, but you know, back when you had a calculator, actually, let me see if I can pull up my calculator on my phone. There we go. If you had a 4-function calculator, let's see if it's not turning for me. That's why. There we go. Come on, Mr. Calculator. If you turn your phone to the side, it actually gives you a 4-function calculator. 4-function meaning add, subtract, multiply, divide. And it actually does give you a log base 10 button, and it actually gives you an ln button also, which is pretty cool, log base E. But this is what you would be given, you know, back in the day, we weren't given the graphing calculators. Yes, I'm that old. We had graphing calculators. My teacher just never let us use them. But the change of base rule says, hey, you can take any log base A of x, and you can rewrite it as log of a different base divided by that whatever base you choose, 10, 2, whatever base you choose. Just take this bigger number, put it here, and take whatever this base number is and put it here. And you can even do that with anything. So for example, log base 5 of 17, you can actually rewrite this to be log base 10 of the bigger number 17 over log base 10 of 5 of that smaller number. You just keep these a different base. It's called change the base. So what you would do is on these 4-function scientific calculators, oops, you would go over here just to show you, and you type log base 10 of 17. So I think on my calculator, you have to do 17 and then hit that, 1.23, and then divide it by 5 log base 10, and then hit equals 1.76. Just to show you on the calculator, you can do, again, you hit the word log 17, divide log 5, and you get 1.76. And you could, again, I showed you how to do it, but you could do math base, log base, and put the 5 here and the 17 here, and they should be the same answer. Yeah, look at that. They're the same answer. You could also do ln, by the way, ln 17 divided by ln 5, because remember, ln is just a base of E. So if I type ln 17 divide ln 5, I get the same answer, because that's the change of base rule. It just says, hey, you can change the base to whatever you want, and it'll always get out. So pretty neat, but just unnecessary if you have that lovely button that I just showed you tonight. So use log base on your calculator because it's so much easier. All right, well, it's 7:30. It should be good. I could stick around for probably about 15 minutes, and then if you have any questions, if not, and you feel comfortable enough, again, please use this time. It gets me frustrated when I have people that don't use this time and they're not doing any homework, and then they're not doing well in the class. So please use this time. If you have any questions, let me know.